February 7, 2009. The fire danger index hit 200, double the scale's supposed maximum. 173 people died. 2,000 homes were gone, and most of those buildings had zero bushfire construction requirements. That disaster rewrote Australian building law. In the next 9 minutes, you'll understand exactly what a bushfire attack level is, what each BAL rating demands from your building, and why getting this wrong can mean the difference between a home that survives and one that doesn't. We'll break down all 6 levels: the assessment process, real construction requirements, and the misconceptions that catch even experienced builders. A bushfire attack level, or BAL, is Australia's system for measuring how severely a bushfire could attack your building. It's defined in AS 3959, the standard for construction of buildings in bushfire prone areas. The BAL system measures one thing: radiant heat flux in kilowatts per square meter. There are 6 levels. BAL-LOW means no specific threat. BAL 12.5 means up to 12.5 kilowatts per square meter, mostly ember attack. BAL 19, BAL 29, and BAL 40 increase through moderate to very high radiant heat exposure. And then there's BAL-FZ, the flame zone, where direct flame contact is expected. Here's the critical insight most people miss: the numbers in each rating are the actual radiant heat flux your building must withstand. BAL 29 means 29 kilowatts per square meter. Later, we'll see what happens when buildings face heat loads they weren't designed for. Before we go further, you need to understand something that changes how you think about every BAL level. 90% of homes lost in Australian bushfires are destroyed by ember attack, not direct flame contact. Embers from burning eucalyptus bark can travel several kilometers ahead of the fire front. They land on your roof, in your gutters, through gaps in your walls. And here's the number that should keep you up at night: embers can enter your building through gaps as small as 2 millimeters. That's thinner than a matchstick. This is why even the lowest BAL rating, BAL 12.5, focuses primarily on sealing your building against ember intrusion. Every gap, every vent, every junction. It's not about building a fortress against flames. It's about keeping burning embers out. So, how does your site actually get a BAL rating? As 3959 uses 4 key inputs. First, the fire danger index for your region. This varies by state: 100 in Victoria and parts of New South Wales, 80 in South Australia and Western Australia, down to 40 in Queensland. Second, vegetation classification. The standard defines 7 types, from dense forest carrying 35 tons of fuel per hectare down to open grassland. Third, distance from that vegetation to your building. Only vegetation within 100 meters counts, though you assess everything within 150. And fourth, the slope of the ground under the vegetation, not between the vegetation and your building. Steeper downslopes mean faster fire spread and higher radiant heat. Feed these 4 inputs into the lookup tables, and you get your BAL, a qualified BPAD accredited assessor, that's Bushfire Planning and Design, does this assessment. For complying development, you need a Level 3 accreditation. Get it wrong, and your building approval gets refused. Let's walk through what each level actually demands from your construction. BAL-LOW is simple: no specific bushfire construction requirements beyond standard building code. Your site has been assessed and the risk is negligible. BAL 12.5 is where it starts. The focus is ember protection. All gaps must be sealed to 2 millimeters maximum. Windows need 4 millimeter toughened glass with ember screens on every openable window. Your roof must be non-combustible. Below 400 millimeters from ground level, walls need non-combustible materials: brick, concrete, or cement sheet. The cost impact at this level is modest. You're mainly paying for gap sealing and ember screens. BAL 19 steps it up. Glass thickness increases to 5 millimeter toughened. Your roof must be fully sealed, and box gutters must be non-combustible. It's the same ember defense philosophy, just tightened. These 2 levels cover the majority of building sites in bushfire-prone areas across Australia. BAL 29 is where the requirements significantly escalate. This is no longer just about embers. You're now defending against serious radiant heat. Windows need external glazing protection screens, steel or bushfire resisting timber frames with 2 mm corrosion resistant mesh. Wall requirements now apply to the full wall height, not just below 400 millimeters. Your entire roof must be socked if tiled. Fascias and barge boards need to be bushfire resisting timber or metal, and every vent needs ember guards with 2 mm mesh. BAL-40 pushes further. Windows must comply with AS 1530.8.1 testing, or use steel or aluminum frames with 6 mm toughened safety glass. External elements must be tested systems. You can't just specify standard products anymore. And here's something that surprises many builders. At BAL-40 and above, your decking must be non-combustible with no spacing between boards. The timber deck you wanted? Gone. BAL-FZ, the flame zone. Direct flame contact is expected. This is where construction gets extreme and expensive. Walls must achieve a fire resistance level of 30-30-30 or be tested to AS 1530.8.2, a more rigorous test than BAL-40 uses. Windows and doors need an FRL of -30 or tested systems to the same standard. Your roof, floor, and subfloor structure all need fire rated or tested solutions. And here's the detail that catches people out. At BAL-FZ, aluminum is banned for screening mesh. Why? Because aluminum melts at 660 degrees Celsius, well within flame zone temperatures. Only corrosion resistant steel or bronze is permitted. For some building elements at BAL-FZ, there are no standard construction solutions. You can only achieve compliance through tested proprietary systems. This level can add over $100,000 to your build cost. Some consultants suggest a $20,000 bushfire certified bunker might be a smarter investment than upgrading every element to BAL-FZ. Let's clear up the misconceptions that get people into trouble. Number 1. BAL compliance does not make your home fireproof. As 3959 explicitly states, there is no guarantee of survival. Compliance means meeting minimum requirements for the assessed risk. Survival also depends on vegetation management, property maintenance, and your own behavior during the fire. Number 2. Your BAL rating is not permanent. Changes to vegetation, whether yours or your neighbor's, can alter your BAL. Certificates are only valid for 12 months. A reassessment can potentially lower your rating. Number 3. Cheap land in a high BAL zone is not a bargain. A block at BAL-40 might look affordable, but once you add the construction premium, you might have been better off buying expensive land at BAL-LOW. And number 4. Any builder cannot handle bushfire construction. 2 mm gap tolerances, specific mesh types, tested systems. This requires specialist knowledge. In March 2018, a bushfire swept through Tathra on the New South Wales south coast. 65 homes were destroyed, 48 damaged. No one died, thankfully. But the investigation revealed something alarming. 50% of the destroyed properties were not in a designated bushfire prone area. They had no BAL rating, no construction requirements, nothing. The mapping system had failed them entirely. On individual streets, BAL ratings zigzagged. One house at BAL-29, its neighbor at BAL-LOW. The fire didn't care about the map boundaries. This case study drives home a critical point. The BAL system is only as good as the mapping and assessment behind it. If your property sits near the boundary of a bushfire prone area, understand that fire doesn't read planning overlays. The system is improving, but it is not perfect. Australia's BAL system is considered one of the most mature wildfire building frameworks in the world. But how does it compare? California uses fire hazard severity zones: moderate, high, and very high. But here's the key difference: California applies largely uniform construction requirements across all zones. Australia graduates its requirements precisely to the measured hazard. The International Wildland Urban Interface Code used by other US states has three construction classes, closer to Australia's approach. Canada only recently developed its first national wildfire building guide. And Europe, despite devastating wildfire seasons, Comprehensive building standards for wildfire prone areas barely exist. Australia's graduated science based approach, 6 levels tied directly to radiant heat flux, sets the global benchmark. But as Tathra showed, the framework is only as strong as its implementation. So, what do you actually do with all this? If you're building in a bushfire prone area, step 1: get a proper BAL assessment from a BPAD accredited assessor. For complying development, that must be level 3 accreditation. Don't rely on self assessment tools for anything beyond initial planning. Step 2: understand that your BAL drives every construction decision, from glass thickness to wall systems to gap sealing. Brief your builder early and verify they have bushfire construction experience. Step 3: remember that compliance is the floor, not the ceiling. Maintain your property. Clear gutters, manage vegetation within your defendable space, seal any new gaps that develop over time. And if you're an architect or building designer specifying for bushfire prone areas, know AS 3959 inside out. The construction escalation from BAL 12.5 to BAL-FZ is dramatic, and getting the details wrong doesn't just fail compliance, it fails the people living inside.